Slow down there, son. Before you start lighting stuff on fire, there are a few scientific concepts you're going to have to wrap your head around. The first one is enthalpy. Enthalpy is a Greek word which translates literally to heat flow. Enthalpy is the transfer of heat. Enthalpy is what melts an ice cube in your hand. Enthalpy is what makes you hot when you stand out in the sun. Enthalpy is the transfer of heat from one thing to another. In this case, enthalpy is the transfer of heat from what is burning to the outside air and concrete on the ground. Hold on, we're not done just yet. There's another concept we have to go over. This one is called entropy. Entropy is chaos, randomness, unpredictability. When you drop food dye into a glass of water, the food dye disperses to fill the entire glass, and instead of initially being a small drop in the middle of the glass, it spreads out to make all the water a light shade of whatever color you dropped in. This concept is everywhere in the universe. The universe is constantly getting more disordered. If we can imagine from the Big Bang, when we were an unimaginably small and densely packed ball of whatever, and then we spread out into what we now know as the universe and continue to expand, that's another example of entropy, just like the drop of food dye dispersing in the glass of water. In this case, entropy can be seen in the air around the burning mass. We see the air moving faster when we go near it. It's hotter. It's in a very unpredictable state, with the molecules moving so quickly. Cool your jets. There is one final concept we have to go over. That is free energy. In the example we show here with the burning matchbox, the system is losing free energy. That means that the reaction is spontaneous. A spontaneous reaction is a reaction which, once started, will continue to completion. For example, lighting a piece of paper on fire. Once you have lit it, the paper will continue to burn until it is all consumed. A counterexample of this is photosynthesis. Photosynthesis is a non-spontaneous process, one in which the free energy is increasing, because photosynthesis stops as soon as the sun goes away. Photosynthesis does not occur at nighttime. Whatever the plant's environment may be, it will not spontaneously go through the process of photosynthesis because it requires a constant contact with sunlight. This is unlike burning paper, which is a spontaneous process. Once we have lit the paper, regardless of whether it's day or night, the paper will continue to burn. The change in free energy is calculated using temperature, enthalpy, and entropy. And it is calculated in a way that determines if the change in free energy is negative, then the process is always spontaneous. And if the change in free energy is positive, then the process is always non-spontaneous. That was a lot. Now, let's review this all. Enthalpy is the transfer of heat from one thing to another. Entropy is chaos, randomness, disorder. Free energy is the energy available for action. If the change in free energy of a reaction is negative, then the process is spontaneous. If the change in free energy of a reaction is positive, then the process is non-spontaneous. Always. A spontaneous process is a process that, once started, will continue without any further assistance. Being spontaneous does not mean that a process occurs immediately.